Okay, so here's some extra homework help for section 1.5. This is all about, again, angle pairs and special angle types. So, um, anyway, number one, let's say, name two obtuse vertical angles. Number vertical angles are angles that look like, let's go off page for a second here, this. And they're angles where they intersect at a vertex and they're opposite of each other. And the key to vertical angles is that they are congruent to one another. So the way I've drawn this here, I've got a pair of acute vertical angles here and a pair of obtuse vertical angles here. And looking in the drawing, you're looking for a pair of obtuse angles. Now, it kind of jumps out at you, hopefully, that there's only two of them, right here and right here. And then one of the things we have to always argue is, do we know if this is really obtuse? In this case, we do, because we have to go back to some old geometry that you should technically know, but then I'm going to teach you later on, so you don't know it. It's kind of silly. But we have a triangle here, right through here, this little triangle. And triangles are 180 degrees. And this is 50 and this is 90, so that only leaves right here for this angle 40 degrees, which means that if this is 40, then this is going to end up being 50 here, and this is going to end up being another angle that's big. So we got all kinds of right triangles and obtuse angles, and we know these two angles here are obtuse. So what's our pair of obtuse vertical angles? Well, angles GFH and angle CFE or BFE. It doesn't matter what you use. I'm just going to do angle CFE because C is easier, right? I guess. I don't know. 2. Name a linear pair whose vertex is B. Now, a linear pair is a pair of adjacent angles that form a line. But more importantly, the easiest way to think of it is this. Think of a line, look for a line somewhere in the drawing, and then think of two angles that shoot off it using a ray. So here's what we're looking at. Vertex is angle B, so there's B. Or point B, sorry, point B. So here's B, so what we're looking for is what's the line that goes through B. Oh, here it is right here. And then here's that ray that shoots off of it. So you have these angles here, I'll number them 1 and 2. So angle GBC and angle ABC. Okay. And then I'll jump to 4. I'll leave 3 for you because I can't do all these. But number 4, this one because I think it's a tough one for a lot of people, but it gets back to linear pairs. One of the things we talk about linear pairs is that they are supplementary. Why? Because they add to 180. And we'll spend time in chapter 2 really getting into this. We use all these properties in this chapter here really throughout the rest of the year, but we really hammer them in chapter 2. So name an angle adjacent and supplementary to DBC. Well, here is DCB. I was like, that doesn't even make sense. Not possible. So here's DCB, this angle right here. And I need an angle adjacent to it, meaning it has to share a vertex and a side. Well, if I've got DC, I've got a couple different ways I could be adjacent to it. I could be adjacent with this angle here, which is angle DCH. Or I could be adjacent over here because I share BC then as a side and be GCB. Either of those work. Okay, but the reason they work is that if they're adjacent and supplementary, they're forming a linear pair. So that's what we're basically asking is this. Hey, can you give me a pair of angles with DCB that gives us a linear pair? And we have one right here and one right here. Okay. All right. Next problem to take a look at, jumping down to number 6. This one's always tricky for people to do. Is if a supplement of an angle has a measure of 78 less than the supplement, all that stuff's tricky. So here's how we're going to do this. We're going to say, this is always the way I do it. So I guess read the question first. If a supplement of an angle has a measure of 78 degrees less than the measure of the angle, what are the measures of the angles? Now again, this is a lot to unpack and it's always confusing. So here's what I always say to do. Call one of these angle 1, call it X, and then call the other one the supplement. Okay. Now what you know is angle 1 and its supplement have to add to 180 degrees. Okay. We know it has to work out. Angle 1 plus the supplement has to be 180. So x plus something has to be 180. Well, what's the relationship? The supplement of an angle has a measure that is 78 degrees less than the measure of the angle. So the supplement is 78 degrees less than this guy. So how do I do that? X minus 78. So if this is 120, it means I should take off 78 to get to this angle. So now my equation is x plus x minus 78 equals 180. Algebra for this, combine like terms, x and x is 2x, add 78, cancels off, 2x, just jump it up over here, is 258 divided by 2, x is 129, and then the other angle is that minus 78, so 129 minus 78, 1, 5. So other angle is 51. So what are the two angles? 129, 51. All right. And then we'll do number 7. Because I don't have to do all these because, again, this is getting too long as it is. If the measure of angle FGE is 5x plus 10, okay, so here's FGE, 5x plus 10. Find the value so that FC and AE are perpendicular. Now, perpendicular means they form a right angle. So they've drawn it here, which is kind of confusing, but really they shouldn't have drawn the right angle, and they should have just left it be, and then you have to assume that, oh, since they had to be perpendicular, they form a right angle. So really the question is this. Find x so that 5x plus 10 is 90. So subtract 10. Divide by 5. X is 16. Okay. And then the last few problems here, 9, 10, and 11. Okay. So the question is assume, determine from the statement whether each can be assumed from the figure. So let's see here. Number 9, NQO, and OQP are complementary. Now, complementary means adds to 90. Okay, they add to 90 degrees. If you look at NQO and OQP, man, they do look like they're right angles. But here's the problem. Is there anywhere in the drawing that tells us this is a right angle? No. So what that means is this could be like 89 degrees here, and this guy here could be 91 degrees, and it's going to look like a right angle. But it's not. And I know some of you are saying, well, it looks like it, and chances are it probably is. I mean, the book's not dumb. They're going to draw a right angle in there, but they're trying to see, do you know it? And the answer is no. We don't know if it's a right angle. Okay. So that's what we'd have to know in order for those two angles to be complementary. Number 10, SRQ, and QRP. That's a linear pair. Do we know that? We can assume yes. And the reason is this. They share a common ray. And here's the key to this. This is safe to assume it's a line. And the reason that's true is the way it's drawn. If it's a ray, they got to make it look more. If they're just kind of weird opposite rays, they got to give you more. Non-opposite rays, they got to give you a little bit more in the drawing. So since it's a pretty straight line, yes, we could say SP is a line and QR is a ray that goes off of it, so it has to be a linear pair. And then MQN, so MQN, gosh, I got colors everywhere. MQN and MQR. Are they vertical angles? No, they don't even match the definition. If anything, they're just adjacent. So no, they're just adjacent angles. And vertical angles can't be adjacent. And by definition, vertical angles are non-adjacent opposite angles. Okay, so yeah, I apologize. That was a long one. It's a longer assignment as far as there's a lot of stuff going on with it. So again, if you have any questions, come in, see me in the morning or channel 1 or something like that. We'll sort out what's going on.